To locate a copy of the 1897 National Electrical Code, there are several avenues to explore. Firstly, consider contacting the Underwriters Laboratories archives. Their email address is, and their phone number is 847 664 1430. They may possess a copy within their archives. Secondly, investigate library resources. The National Fire Protection Association Library may have relevant materials. Their website is NFPA. org/news and research/publications and media/NFPA journal/2017/May/June/features/NFPA Library. The National Archives and Records Administration, also known as NARA, is another potential source. Their website is archives.gov/research/arc/. The Library of Congress may also hold a copy. Their website is luck.gov/. Additionally, consider exploring online retailers. Amazon offers a reprint of the 1897 National Electrical Code. Barnes & Noble also carries a copy. A-Books may have listings for the 1897 National Electrical Code as well. It is important to note that the print published by Amazon and Barnes & Noble is a facsimile edition, and it may not be an exact copy of the original. NARA and the Library of Congress may have copies in their physical archives. You may need to visit these institutions in person or request a copy through the interlibrary loan services. The National Fire Protection Association is the current publisher of the National Electrical Code, often referred to as the NEC. They may have access to historical copies or be able to provide assistance in locating a copy. When researching the National Electrical Code, it's crucial to understand its purpose and evolution. The NEC is a comprehensive set of standards and guidelines for safe electrical installations. It covers various aspects of electrical wiring, equipment, and systems in buildings and other structures. The code is updated regularly to reflect advancements in technology, safety practices, and industry standards. The National Electrical Code is not law unless it is adopted by a local or state jurisdiction. These jurisdictions often amend the NEC to suit local needs and conditions. Electrical inspectors use the NEC as a benchmark for evaluating electrical installations for safety and compliance. The code provides specific requirements for conductor sizing, overcurrent protection, grounding, wiring methods, and equipment installation. It also addresses specific types of occupancies and equipment, such as hazardous locations, healthcare facilities, and swimming pools. The NEC is organized into chapters, articles, and sections. Each section provides detailed requirements for a specific aspect of electrical installations. For example, Article 250 covers grounding and bonding, while Article 310 addresses conductors for general wiring. When working with electrical systems, it's essential to consult the latest edition of the NEC and any applicable local amendments. Understanding the code requirements and applying them correctly can help ensure the safety of people and property. The NEC also includes tables and examples to aid in the application of its requirements. These tables provide information on conductor ampacity, conduit fill, and other calculations. The examples illustrate how to apply the code requirements in specific situations. The NEC is a living document that evolves over time. New editions are published every 3 years to incorporate changes and updates. It's important to stay current with the latest edition of the code to ensure that electrical installations meet the latest safety standards. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These include standards from organizations such as Underwriters Laboratories, the Institute of Electrical and Electronics Engineers, and the American National Standards Institute. It's important to be aware of all applicable standards and regulations when designing and installing electrical systems. The NEC is a valuable resource for electricians, electrical engineers, inspectors, and anyone involved in the electrical industry. It provides a comprehensive set of guidelines for safe electrical installations, protecting people and property from electrical hazards. When using the NEC, it's important to understand the definitions of key terms. The code includes a glossary of terms that are used throughout the document. These definitions help to ensure that the code requirements are applied consistently. The NEC also includes information on the proper selection and installation of electrical equipment. The code specifies requirements for equipment listing, labeling, and installation. It's important to use equipment that is listed and labeled for its intended use and to install it according to the manufacturer's instructions and the NEC requirements. The NEC addresses a wide range of electrical hazards, including shock, arc flash, and fire. The code provides specific requirements to mitigate these hazards and protect people and property. For example, the code requires the use of ground fault circuit interrupters in certain locations to protect against electric shock. The NEC also requires the use of arc flash protection in certain situations to protect workers from arc flash hazards. The NEC is a complex document, but it is essential for anyone involved in the electrical industry. By understanding the code requirements and applying them correctly, you can help ensure the safety of electrical installations. The National Electrical Code is a critical resource for electrical safety, covering a wide range of topics, including wiring methods. Wiring methods encompass the types of cables, conduits, and other raceways used to route electrical conductors. The NEC specifies the allowable wiring methods for various applications and environments. Common wiring methods include non-metallic sheet cable, often referred to as NM cable or Romix, which is typically used in residential wiring. Another common wiring method is electrical metallic tubing, known as EMT, a thin-walled conduit often used in commercial and industrial applications. Rigid metal conduit, or RMC, is a heavy-walled conduit used for more demanding applications where greater physical protection is required. Liquid-tight flexible metal conduit, known as LFMC, is a flexible conduit used in wet or damp locations. Cable trays are used to support and route cables in industrial and commercial buildings. The NEC specifies the requirements for the installation of each wiring method. These requirements address issues such as support, spacing, and protection from physical damage. The NEC also specifies the types of conductors that can be used with each wiring method. Conductors are the wires that carry electrical current. The NEC specifies the allowable ampacity of conductors, which is the amount of current that a conductor can safely carry. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. The NEC includes tables that provide the ampacity of conductors under various conditions. The NEC also addresses the issue of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. The NEC specifies the required overcurrent protection for each circuit. The size of the overcurrent protection device must be matched to the ampacity of the conductors in the circuit. The NEC also addresses the issue of grounding. Grounding is the process of connecting electrical equipment to the earth. Grounding helps to prevent electric shock and minimize the risk of fire. The NEC specifies the requirements for grounding electrical systems and equipment. The grounding system must be properly installed and maintained to ensure its effectiveness. The NEC also addresses the issue of bonding. Bonding is the process of connecting metallic parts of electrical equipment together to create a low impedance path for fault current. Bonding helps to prevent electric shock and minimize the risk of fire. The bonding system must be properly installed and maintained to ensure its effectiveness. The NEC also addresses the issue of surge protection. Surge protection devices are used to protect electrical equipment from voltage surges caused by lightning or other events. The NEC specifies the requirements for surge protection in certain applications. The surge protection devices must be properly installed and maintained to ensure their effectiveness. The NEC is a complex document, but it is essential for anyone involved in the electrical industry. By understanding the code requirements and applying them correctly, you can help ensure the safety of electrical installations. The National Electrical Code addresses numerous specific applications, including hazardous locations. Hazardous locations are areas where flammable gases, vapors, dust, or fibers may be present in the air in sufficient quantities to cause explosions or fires. The NEC classifies hazardous locations into different classes and divisions based on the type of hazardous material and the likelihood of its presence. Class 1 locations are those where flammable gases or vapors are present. Class 2 locations are those where combustible dust is present. Class 3 locations are those where ignitable fibers or flyings are present. Each class is further divided into divisions based on the likelihood of the hazardous material being present under normal or abnormal conditions. Division 1 locations are those where the hazardous material is present under normal operating conditions. Division 2 locations are those where the hazardous material is present only under abnormal conditions, such as a spill or equipment failure. The NEC specifies the types of electrical equipment that are permitted in each class and division of hazardous locations. Electrical equipment used in hazardous locations must be designed and approved for use in those locations. This equipment is typically explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain an explosion within the enclosure, preventing it from igniting the surrounding atmosphere. Intrinsically safe equipment is designed to operate at low voltage and current levels so that it cannot produce enough energy to ignite the hazardous material. The NEC also specifies the wiring methods that are permitted in hazardous locations. Wiring methods used in hazardous locations must be designed to prevent the ignition of the hazardous material. These wiring methods typically include rigid metal conduit with explosion-proof fittings. The NEC also addresses the issue of bonding and grounding in hazardous locations. Bonding and grounding are essential for preventing the buildup of static electricity, which can ignite the hazardous material. The bonding and grounding system must be properly installed and maintained to ensure its effectiveness. The NEC is a complex document, but it is essential for anyone involved in the electrical industry. By understanding the code requirements and applying them correctly, you can help ensure the safety of electrical installations in hazardous locations. The NEC also covers specific requirements for swimming pools, spas, and hot tubs. These locations present unique electrical hazards due to the presence of water, which can conduct electricity. The NEC specifies the requirements for bonding and grounding of all metallic parts of the pool, spa, or hot tub structure, including the reinforcing steel, metal fittings, and electrical equipment. Bonding and grounding help to prevent electric shock by creating a low impedance path for fault current. The NEC also requires the use of ground fault circuit interrupters for receptacles and equipment located near swimming pools, spas, and hot tubs. Ground fault circuit interrupters, known as GFCIs, are designed to protect people from electric shock by detecting small leakage currents and interrupting the circuit. The NEC specifies the minimum distance that receptacles and equipment must be located from the water's edge. This distance is intended to prevent people from accidentally touching electrical equipment while they are in the water. The NEC also specifies the requirements for underwater lighting in swimming pools. Underwater lighting must be listed for use in swimming pools and must be installed in accordance with the manufacturer's instructions. The NEC also addresses the issue of overhead power lines near swimming pools. Overhead power lines must be located a safe distance from the pool to prevent accidental contact. The NEC is a complex document, but it is essential for anyone involved in the electrical industry. By understanding the code requirements and applying them correctly, you can help ensure the safety of electrical installations around swimming pools, spas, and hot tubs. The National Electrical Code is a living document constantly evolving to address new technologies and safety concerns. The process of revising the NEC involves input from a wide range of stakeholders, including electrical engineers, contractors, inspectors, manufacturers, and consumers. The NEC is revised on a 3-year cycle. The process begins with the submission of proposals for changes to the code. These proposals are reviewed by code-making panels, which are composed of experts in various areas of electrical safety. The code-making panels develop revisions to the NEC based on the proposals they receive. The proposed revisions are then published for public comment. The public is invited to submit comments on the proposed revisions. The code-making panels review the public comments and make further revisions to the code as necessary. The final version of the NEC is then published and becomes effective. The NEC is adopted by many jurisdictions throughout the United States and around the world. When a jurisdiction adopts the NEC, it becomes law in that jurisdiction. The NEC is a valuable resource for electrical safety. By understanding the code requirements and applying them correctly, you can help ensure the safety of electrical installations. The NEC is not intended to be a design manual. It provides minimum safety requirements, but it does not provide detailed design guidance. Electrical engineers and designers must use their professional judgment and experience to design safe and reliable electrical systems. The NEC is a complex document, but it is essential for anyone involved in the electrical industry. By understanding the code requirements and applying them correctly, you can help ensure the safety of electrical installations. The NEC also addresses renewable energy systems such as solar photovoltaic, also known as PV, systems and wind power systems. These systems are becoming increasingly common as people seek to reduce their reliance on fossil fuels. The NEC specifies the requirements for the installation of renewable energy systems. These requirements address issues such as grounding, overcurrent protection, and disconnects. The NEC also specifies the requirements for the interconnection of renewable energy systems with the electric grid. The interconnection must be done in a safe and reliable manner to protect both the utility grid and the renewable energy system. The NEC is a complex document, but it is essential for anyone involved in the electrical industry. By understanding the code requirements and applying them correctly, you can help ensure the safety of electrical installations, including renewable energy systems. It's important to remember that electrical work can be dangerous. Always follow safe work practices and consult with a qualified electrician if you have any questions or concerns.